Hello everyone, welcome back to my channel. It's me Abhay. So today we are going to the second part of vectors, which is vectors part 2. Okay, so without wasting any further time, let us go into this video. So what and all are we going to learn in this video? First, we will learn something called as representation of vectors. We learn 3D geometry in vectors. We learn types of vectors. We will also learn to find the magnitude of a given vector. We will also learn to find unit vector of a given vector. All these things we are going to cover in this video. Clear? First part, representation of a vector. You all know what a vector is? Yes, a vector is a quantity which has both magnitude and direction, correct? It has both magnitude and direction. Let us say you have a quantity A and you want to say it is a vector. How do you specify it as a vector? Let us see. That is what we are going to learn now. Okay. How do you represent that vector? Let us see. A vector is represented using an arrow mark and it has two parts. Okay. Two parts. Now, this part, what you can see, is called as head, and this ending part is called as a tail. This head part, na, it represents direction. Okay, which direction it is moving it represents, and this tail part represents starting point. It represents starting point. Okay, simple. Now let us say you have A and you want to represent it as a vector. How do you know? How do you represent it? Simple. You apply an arrow marker above it. This represent A is a vector. How do you read it now? Vector A or A vector. This is B. This is B vector. This is K. This is K vector. This is F. This is F vector. Clear? Understood? Simple. Next, we are going to learn 3D geometry in vector. Okay. In basic of mathematics, I already taught you about 3D plane. Yes. So this is what positive x-axis. This is y-axis. This is z-axis. And I told you there to remember I cap, j cap, and k cap. Okay. I told you we learn it in vectors. Here you will learn those things. Now, x-axis consists of plus I cap and minus I cap. Okay. Now, what is I cap first of all? Now you're starting from the origin and you are taking a vector of magnitude 1 unit in positive x-axis. This is I cap. Okay. What is minus I cap? Opposite direction. You are taking it here. This is minus I cap. Okay. Unit vector. What is unit vector? A vector whose magnitude is 1 unit. That is unit vector. Now, a unit vector in positive x-axis, okay, is plus I cap. Unit vector in negative x-axis is minus I cap. Okay. Now, assume you have one vector which is pointing in this direction. Unit vector. Is it I cap or minus I cap? This arrow mark points towards positive x-axis. So this is I cap. Clear? What is j cap? J cap is unit vector pointing towards positive y-axis and minus j cap points towards minus y-axis. Z-axis has k cap which points towards plus z-axis and minus k cap points towards minus z-axis. Here, this is x, this is minus x, this is y, this is minus y, this is z, and this is minus z. Clear? That's it. Next part. Vector plus 3D geometry. We'll combine both vector and 3D geometry. Now, assume you have a vector which is xi cap, yj cap, and zk cap. Okay? How do you represent in a 3D plane? As simple as that. This represents positive x coordinate or x coordinate. That's all. X coordinate. It represents x coordinate. This represents y coordinate, and this represents z coordinate. Clear? Now, a point in a 3D plane is represented using the form x comma y comma z. No. If we have xi cap, yj cap, and zk cap, Look at the point x, y, z and draw a vector whose tail is at origin and head is at this point. So this is nothing but xi cap plus yj cap plus zk cap. Is this clear? Tell me. That's it. Okay. Oh, assume. Okay. You have 2i cap plus 3j cap and you want to represent it. Okay, this is x coordinate x, this is y, and this is z axis. Okay, now you want to represent this vector 2i cap plus 3j cap. How do you do? This is 1, this is 2, 2 comma 3. Here is some point 2 comma 3 comma, there is no z axis, so 0, and this vector is 2i cap plus 3j cap. Clear? This is how you represent a vector in a 3D plane. Next, we'll talk about types of vectors. Vectors are of many types, okay? So we'll see the different types of vectors now. First, you have parallel vectors. What are parallel vectors? Parallel vectors, you know the meaning, which means they point towards the same direction and they need not have same magnitude. So these two are parallel vectors. Okay. You have like this, you have like this. These two are parallel vectors. Now, what is anti-parallel vectors? Anti-parallel means what? Or negative vector is what? In opposite direction. This is anti-parallel. This is anti-parallel. This is anti-parallel. Okay. What are equal vectors? Equal vectors are those vectors which have same magnitude and same direction. These two are equal vectors. These two have equal vectors. Okay, these two are equal vectors. Clear? Collinear vectors. What are collinear vectors? What is collinear? First of all, they lie in the same line. Okay, these two are collinear vectors. Correct? They lie in the same line. These two are collinear vectors. Now, are these two collinear vectors? No, this is not collinear vectors. Okay, you have like this. You have like this. These two are collinear vectors. Clear? The next part, collinear vector. Next part, coplanar vectors. What are coplanar vectors? Coplanar vectors, we will be talking about three vectors. Okay. Here we will be talking about minimum you need three vectors. How do you tell the three vectors are coplanar? Okay. Assume you have one vector like this, one vector like this, one vector like this. You need to take a sheet and all these vectors needs to lie on the sheet. Only then it is said to be coplanar, which means they lie in the same plane. If one vector is coming out or it is like slightly coming out or going in, that those three vectors are said not to be coplanar. Okay. Now, assume you have one vector like this, you have one vector like this, a vector like this. Is it coplanar? No, because one plane is like this, but this vector is what coming out. Okay. So this is not coplanar. Clear? Next, unit vector. What is a unit vector? Unit vector is a vector whose magnitude is 1 unit. Okay, whose magnitude is 1 unit. Such a vector is said to be unit vector. Now, what is co-initial vector? As two or more vectors having the same starting point, eh, those vectors are said to be co-initial vectors. Okay. Assume you have two vectors. One is like this A, another vector B. These two vectors are said to be co-initial vectors. Or for easy definition, you can tell their tails coincide. Vectors whose tails coincide, such a vector is said to be co-initial vectors. Is this clear? Next, finding the magnitude of a given vector. Now, let us say you have a given vector and you want its length. The length, the distance from head to the tail is called magnitude. Okay, I forgot to mention it. Note it down. The distance from its tail to head is called magnitude. Now, how do you find the magnitude? How do you find the length? Let us say you have a vector 3i cap plus 4j cap plus, let us say, 10k cap. Okay, you want to find the magnitude of this vector. How do you find? That is what we are going to learn in this topic. Okay, let us first, what is the formula? Now, okay, before going to the magnitude formula, all of you know distance between 2 points. Okay, from 2D geometry, which is what? Root of x2 minus x1 ka whole square plus y2 minus y1 whole square from 2D geometry. In 3D geometry, what are you going to do? You are going to add z2 minus z1 whole square. That's it. This is what? Distance. Now, to find out the magnitude of a vector, how do you find now? How do you find the magnitude of a vector? See, assume you have this vector, okay, x, comma y, comma z. How do you represent this vector? X I cap plus y j cap plus z k cap. This is how you represent. Now, if you want the magnitude, don't you think it's distance of this point from the origin? Correct. It's distance of x, y, z from the origin. So what you are going to do? You will just put x1, x, y1, y1 and z1 as 0 and x2 as x, y2 as y, z2 as z. Correct, na? This is what? X2, x1, x2, y2, z2 only. That is what you are finding. This is point, this is point A and this is point B. Okay. So x, y, z. So what you are going to do? What are you going to get now? Just what? X comma y comma z. So what are you going to get? Root of. This is the vector. So you are going to get x minus 0 whole square plus y minus 0 whole square plus z minus 0 whole square, which is nothing but root of x square plus y square z square. So don't you think you can tell magnitude of x I cap plus y j cap plus z k cap is nothing but this. That's it. Okay, that's all. Simple. Understood the derivation? Okay. Now we will solve some questions. Pause the video and try it. Okay. Before trying the question, okay, I have a shortcut method. Okay. Now let us say you have x I cap, y j cap, and z k cap. Quickly, if you want to find the magnitude without using any formula, just remember this square, this square, this square. Okay, add all of them and put a root. That's all. Okay, now try all of these questions. Try, pause the video and try this question. Now let us solve the first one. You have 4i cap plus 3j cap plus 5k cap. How do you find the magnitude of this? Use the formula root of. Okay, wait, no, it is nothing but root of this square, 4 I cap square, which is this, I mean, coefficient of I cap square plus coefficient of j cap square plus coefficient of k cap square. Remember, coefficient of I cap square, coefficient of j cap square, coefficient of k cap square. Add those two, then take root. So, which is what now? 4 square is nothing but 16, 3 square is 9, 5 square 25, and you are going to get root 50. Okay? So, magnitude of this is nothing but root 50. Okay? Try the second question. Second question will be easier. Here there is no j cap. Okay. So what you will do, you can write it as 0 j cap only. Yes. So just do what I said. Coefficient of I cap square plus coefficient of j cap square plus coefficient of k cap square, which is 5 square, which is what? Root of 12 square is what? 144. 0 square is 0. 5 square is what? 25. So what are you getting? Root of 169, which is 13. Okay. So magnitude of this is 13. And we are going to write units. 13 units. And this is root 50 units. Okay. That's it. Next topic. What is it? Unit vector. So you already learned about unit vector. Yes, you already learned. But let us say you have one. Let us say, okay, let us say you have a vector 6 I cap plus 2 j cap, and you want to find the unit vector of this. How do you find the unit vector of this vector whose magnitude is not 1? Of course, its magnitude is not 1. 36 plus 4 root 40. Its magnitude is not 1. How do you convert it to a unit vector? That we will learn in this topic. Okay, let us. Now, there is a formula to find the unit vector of a given vector. Okay, instead of directly giving you the formula, I will teach you the logic. Okay, let us take a random vector 3I cap plus 4j cap. Okay, let us say this is the given vector. Now, find out the magnitude of this vector first. What is this? Root of 3 square plus 4 square plus 0 square, which is nothing but root of 25, which is 5. Now, this magnitude is 5. So, this is obviously not a unit vector, but you want to convert it to a unit vector. What is the magnitude of a unit vector? 1. So, basically, you want the magnitude of the new vector to be 1. So, what if you just divide this whole vector by 5, by its magnitude? What if you just divide this given vector by its magnitude? What are you going to get? 3 by 5 I cap plus 4 by 5 j cap. Okay. Now just see. You're going to get what? Here you will have 25, of course. Here it's what? 9 square plus 3, yeah, 3 square, that is 9, plus 4 square, 16, which is 25 by 25, which is good. Hence, you have converted this into a unit vector. So, how do you do it? How do you convert it to a unit vector? Nothing. Just write the given vector and divide it by its magnitude. Just whatever vectors they have given, just write that vector without any change. Just divide the whole vector by its magnitude. That's it. Okay? Clear? Let us solve some questions. Pause the video and try these questions. First question. Here you have 6 I cap plus 8 j cap plus 10 k cap. How do you find the unit vector? First, find its magnitude. No, all of you should have found out the magnitude by now. Yes. What is it now? Tell me. It is nothing but 6 square, I cap square, coefficient of I cap square, coefficient of j cap square plus coefficient of k cap square. So, which is what? 100 Yes, 100, which is root of 200. So magnitude of the above vector is what? 200, root of 200. Root of 200, I can write it as 10 root 2. Now, magnitude of the above vector is 10 root 2. You want to find the unit vector. How do you do? What did I tell? Write the vector as it is. Okay, we'll write the vector as it is. 6I cap plus 8J cap plus 10K cap. Okay, first step done. What did I tell? Second step. Divide the whole thing by its magnitude. This is it. Okay. You can split it individually. Write it like 6 by 10 root 2 I cap plus 8 by 10 root 2 J cap plus 10 by 10 root 2 K cap. Simplify it further, rationalize, and you'll get the answer. Okay, that's it. Done. Try the second question. Now, how do you solve? This is J cap. Okay. How do you solve this? Same. First, find out the magnitude. What is the magnitude? Let us see. Nothing but root of 3 square plus 8 square, which is what? Root of 9 plus 64. What are you going to get? Root of 73. So 73 is a prime number. Okay. So now, how do you find a unit vector? Write the vector as it is. Write the vector as it is. Okay. What is it? 3I cap plus 8J cap. Now, then divide it by its magnitude, root of 73. So it is 3 by root. Okay, I'll write it 1 second. Yeah, 1 second. Yeah. So how do you do it? Write the vector as it is. So 3I cap plus 4J cap. Divide individually by its magnitude. Root 73. Root 73. So this is nothing but the unit vector of this question. So that's it. I think this was quite simple. Clear? Next. Homework questions. Okay. Now try these two questions and let me know the answer in the comments. Okay. And those who get the right answer, they will get a surprise. Okay. Solve the question and give the answer in the comments. So that's it. So next topic, what we are going to start is a very, very important topic in the vectors, which is vector addition. Okay, vector addition is not as simple as algebraic addition. So that is why we need a one whole session for vector addition. So do watch that session without fail. Okay. So that's it. Thank you for watching. If you have any doubts, let me know in the comments down below. Thank you. Bye bye.